हेलो स्टूडेंट्स, वेलकम टू परमार अकेडमी। आज हम ग्रेड 10 के थर्ड चैप्टर को डिस्कस करेंगे, दैट इज द पेयर ऑफ लीनियर इक्वेशन इन टू वेरिएबल। सो फर्स्ट ऑफ ऑल, अ लीनियर इक्वेशन, equation having degree 1 is called the linear equation, and next is two variable. Two variable means that equation involves two variable, that I means x and y. And the pair means we are having such pair of two equations like 5x plus 3y equal to 9 and 7x minus 2y is equal to 6. So look at here, this is one of the example of pair of linear equation in two variable. So first of all, pair, there are two equation number 1 and equation number 2. So this is a pair of linear equation. Look at here, the degree of the equation is 1, the degree is 1, the power of x is 1, power of y is 1. Similarly in the second equation also, equation, the equality signs are there, and two variable means there are two variable x and y. So this is one of the example of pair of linear equation in two variable. Now in this chapter we have to deal with such type of equations. The next one is solution. What is the solution of a pair of linear equation in two variable? So a point m comma 1 n is a solution of pair of linear equation in two variable a1 x plus b1 y is equal to c1, a2 x plus b2 y is equal to c2 if it will satisfy both the equations simultaneously. Now what is the meaning of this? That a point m comma n is a point that is a solution of this type of equation if it will satisfy both those equations simultaneously. What is the meaning of simultaneously? Means whatever the solution is, that is satisfy both the equations at a time. So let's take an example. Is 3 comma 1 solution of x plus y is equal to 4 and x minus y is equal to 2? Means we have to check that is 3 comma 1 is the solution of this pair of linear equation, yes or no. So let's try. If this point is a solution of this system of equations, that it will satisfy both the equation. So let's try. This is equation number 1 and this is equation number 2. First of all, we will try for the equation number 1. Equation number 1 is x plus y is equal to 4. Now point is 3 comma 1. So replace x by 3 and y by 1. Left hand side we will get 4 and that is equal to right hand side. So yes, this point satisfy the equation number 1. Now we will try for the equation number 2. So equation number 2 is x minus y equal to 2 and the point is 3 comma 1. So try for this. 3 minus 1, that is 2, and this is also equal to right hand side. So that means 3 comma 1 point satisfy both the equation number 1 and equation number 2. So it is a solution of both the equation. So we will say that 3 comma 1 is the solution of the pair of linear equation in two variable. The next example is 2 comma 1 solution of 3x minus 2y is equal to 4 and 2x plus 4y is equal to 2. Again, the one example is here. We have to check that is this given point solution of pair of linear equation in two variable, yes or no. So again we will try for both the equations. This is equation number 1 and this is equation number 2. Let's for first equation, 3x minus 2y equal to 4 and the point is 2 comma 1. So easily x is replaced by 2 and the y is replaced by 1. This is 3 into 2 minus 2 into 1, that is 6 minus 2, that is equal to 4, and this is equal to right hand side. So that means 2 comma 1 is the solution of first linear equation in two variable. Now let's check for the second equation also, that is 2x plus 4y is equal to 2. Again replace x by 2 and y by 1. So this is 2 2s are 4, 4 1s are 4, that is 8, and this is not equal to right hand side. So 2, 1 is solution of first equation, but it is not a solution of second equation. So overall 2, 1 is not a solution of such pair of linear equation in two variable. Means for the solution of pair of linear equation in two variable, that given point has to satisfy both the equations simultaneously. As in this example, it will satisfy first equation, but it will not satisfy the second equation. So overall it is not a solution of pair of linear equation in two variable. So this is how we have to find, or we have to check the given point is solution of pair of linear equation in two variable, yes or no. The next one is, now in grade 9th, as we know that a single linear equation in two variable represents a straight line on the graph. So similarly, if we are having a pair of linear equation in two variable, so simply it will represent two straight lines on the graph. So pair of linear equation in two variable represents two straight lines on the graph, and there are three possible cases related to the two lines, straight lines. So first case is the two lines intersect each other at a point. So these are the two straight lines, the line L1 and line L2, and this will intersect at a given point. So look at here, in this chapter, as we know that a single point is a solution if it will satisfy both the equations. So that means in graphically, the solution of pair of linear equation in two variable is a point that is common to both the lines. So look at here, in the first case, how many common points are there? There is only a single common point, a one point in common. So there is a one solution. The solution in a pair of linear equation represents a point that is common to both the equation. If there are two common points, there means two solution, 5 common points, 5 solution, 1 common point, 1 solution, no common point means there is a no solution. So similarly, there are only 3 possible cases. In the first case, when the lines are intersecting to each other, there is only one common point. So we will say that there is only one common point. That why it is having a unique solution, means it is having a single solution. And the system is called consistent system. That means solution is possible. For the second case, when the lines are parallel. When the lines are parallel. Now look at here. Between these two lines, there is a no common point. There is no common point between these two lines. So there is a no common point. So we will say that there is a no solution, because I will repeat, solution is the common point to both the equation or both the straight lines. As there is no common point, so there is a no solution, and the system is called inconsistent system, where solution is not possible. The third and the last case is when one line is just upon the second line, means एक line just दूसरे line के just ऊपर है, both the line coincide with each other. Now every point is a common point. Every point of both the lines is a common point. So there are infinite number of points in common. So we will say that there are infinite many solution, because solution is again a common point. So between these two lines, there are infinite points are common. So there are infinitely many solutions. Again, the system is called consistent system, because the solutions are possible. So I will repeat. So what is the solution graphically? Graphically, a solution is a common point to both the straight lines. If we are having two lines, there are only possible 3 cases: case 1, case 2, and case 3. In first case, lines are intersecting, where only one common point is there, so we are having only unique solution. In second case, where only no point is common, so there is a no solution. In third case, every point is a common point to both the lines, so there are infinite common points, so we will say that there are infinitely many solutions. The next one is how to find the solution. The next way is, as we know from the last slide, what is the solution? Solution is a common point to both the equations or the straight lines. Now the content is how to find such solutions. So look at here, there are 4 methods according to NCERT grade 10th. We have to find the solution of pair of linear equation in 2 variable. The first method is substitution method, second is graphical method, third is elimination method, and the fourth is cross multiplying method. In this video, we will discuss the first two methods, that are substitution method and the graphical method. So, the first method is substitution method. So, solve x plus y is equal to 5 and 2x minus 3y is equal to 4 using the substitution method. So, this is a pair of linear equation in two variables. This is the first equation and this one is the second equation, and we have to solve this system of equation using the substitution method. So, very easy. Look at here. The first equation, that is x plus y is equal to 5, and the second equation is 2x minus 3y is equal to 4. What is the first step? Look at here. The first step is we have to find the value of x or y from the equation number 1. So, simply the value of x is equal to 5 minus y. This is the value of x from the first equation. Now, we have to put this value in the equation number 2. Look at here. 2, x is replaced by its value, that is 5 minus y minus 3y is equal to 4. Now, solve this. 2 5s are 10, 2 y's are 2y minus 3y equal to 4. That is 10 minus minus plus, that is minus 5y is equal to 4. 10 minus 4 is equal to 5y. That is 6 is equal to 5y, and the value of y is 6 upon 5. That is the value of y. So, what is the first step? I will repeat. The first step is, from first equation we have to find the value of x or y. When we are having the value of x or y, we will substitute that value in the equation number 2. From there we will get the value of one variable. We will get the value of y, that is 6 by 5. Again put that value in this equation. So, we will get x is equal to 5 minus y, that is 6 upon 5. On calculation we will get 25 minus 6, x is equal to 19 upon 5. So, the overall answer is 19 upon 5 comma 6 upon 5 is the solution of this pair of linear equation in two variable. Now, after getting the solution, we will easily verify that is the solution correct or not. We simply have to substitute these solution in the equations. If it will satisfy both the equations, this solution is correct. So, substitute here x plus y is equal to 5. First equation, x plus y. X is 19 upon 5 plus y, that is 6 upon 5, and the answer is 19 plus 6 upon 5, that is 25 upon 5, that is equal to 5, is equal to right hand side. Our solution will satisfy the first equation easily. Now, let us try for the second equation, that is 2x minus 3y is equal to 4. 2 into x, that is 19 upon 5 minus 3 into y, that is 6 upon 5, that is 38 upon 5 minus 18 upon 5, that is equal to 20 upon 5, and that is 4, is equal to right hand side. So, a solution will also satisfy the equation number 2. So, that means our solution satisfies both the equations simultaneously. So, this is the correct answer for this system of solution. Now, we are having a single solution. So, there is this system having the unique solution, and the lines are intersecting lines because we are having a single solution. So, this system represents a intersecting straight lines. Now, the second question is 3x plus 4y equal to 10 and 2x minus 2y equal to 2. Again, this is the first equation, 3x plus 4y is equal to 10. From here, we have to find the value of x or y from the first equation. So, value of x is, that is 10 minus 4y upon 3. This is the value of x from the first equation. Now, we will substitute this value in the second equation, that is 2 into x, that is 10 minus 4y upon 3 minus 2y equal to 2. Now calculating 20 minus 8y upon 3 minus 6y is equal to 2. I will take LCM here. So this is equal to 20 minus 14y is equal to 6. That is 20 minus 6 is equal to 14y. 14 is equal to 14y, we will get y is equal to 1. Now we are having the value of one variable, that y is equal to 1. We will substitute that value in the equation. This one, x is equal to 10 minus 4 into 1 upon 3. x is equal to 10 minus 4, that is 6 upon 3. So x is equal to 2. So 2 comma 1 is the solution of this system of equations. Now again we will check is the solution correct. So we will trying to satisfy these both the equations. Now first equation, 3 into x, that is 3 into 2 6 plus 4 into y, that is 4 into 1 4. The answer is 10 and that is equal to right hand side. Yes, the first equation is satisfied by this solution. Try for the second, 2x, this is 2 into x, that is 2 into 2 minus 2 into y, that is 1. The answer is 4 minus 2 and the answer is 2, that is equal to right hand side. So this solution will satisfy both the equation. So our answer is correct. That means 2 comma 1 is the solution of this pair of linear equation in two variable. So this is the substitution method. Again I will repeat, in substitution method the first step is we have to find the value of x or y from the first equation, that is like this. Then we have to substitute that value of that variable in the second equation. From there, after calculating, we will get the value of one variable, and after substituting that variable in this equation, we will get the second variable also. So this is the overall method, that is called substitution method. The next one is, if we add, this is a statement problem, if we add 1 to the numerator and subtract 1 from the denominator, a fraction becomes 1. It also becomes half if we only add 1 to the denominator. What is the fraction? So this is the question related to fraction. So we have to find the fraction. Let numerator of the fraction is x and denominator of the fraction is y. So overall the fraction is x upon y. This is the very basic thing. In a fraction there are two parts, numerator and denominator. As we have to find the fraction, let the numerator is x and the denominator is y. So overall fraction is x upon y. Now what is the first condition? If we add 1 to the numerator, if we add 1 to the numerator and subtract 1 from the denominator, fraction becomes 1. The fraction becomes 1. This is the first condition. So just cross multiplying, x plus 1 is equal to y minus 1, that is x minus y is equal to minus 2. This is our first equation. Now what is the second condition? It becomes half, the fraction becomes half if we only add 1 to the denominator. Means there is no change in the numerator, there is only we have to add 1 in the denominator, the equation becomes half. Again cross multiplying, 2x is equal to y plus 1 and 2x minus y is equal to 1. This is the equation number 2. Now we are having a pair of linear equation in two variable. Again using the substitution method we will solve these equations. From here we will get the value of one variable, that is minus 2 plus y. Now substitute this value in this is step 1. Step 2, substitute this value here in the equation number 2, that is 2 into x, that is minus 2 plus y minus y equal to 1. That is minus 4 plus 2y minus y equal to 1. This is 2y minus y, 4 get added that side is equal to 5. So value of y is 5. Again substitute that value here, x is equal to minus 2 plus y, and y is 5, so x is equal to 3. So value of x is 3 and y is 4, so our fraction is 3 upon 5. So fraction is 3 upon 5. If we want to check the solution, we will go through the conditions. Look at here, the first condition is add 1 to the denominator, that is 3 plus 1, 4. Subtract 1 from the denominator, 5 minus 1, 4. The answer is 1. Yes, the answer is 1. First condition satisfied. The second condition is if there is no change in the denominator, means 3 is as it is, and if we add 1 to the denominator, means 5 plus 1, 6. It becomes half. Yes, it becomes half. So our answer, that is 3 upon 5, will satisfy both the conditions. So 3 upon 5 is the correct answer for this statement problem. Now the next one is, 5 years ago Noori was thrice as old as Sonu. 10 years later Noori will be twice as old as Sonu. How old the Noori and Sonu? Now this is a statement problem related to ages. So for that we will divide the question in 3 parts. The first is present ages, that is future ages, and the past ages. As we have to find the present ages, let the present age of Noori is x years and the present age of Sonu is y years. So this is the x and y is the present ages of Sonu and Noori respectively. Now 10 years later Noori will be twice as old as Sonu, but this is the second condition. The first condition is 5 years ago. 5 years ago means in the past. 5 years in the past. So Noori's age 5 years ago is x minus 5 and Sonu's age 5 years ago is y minus 5. The Noori was thrice as old as Sonu. The Noori is thrice as old as Sonu means Noori is elder than as compared to Sonu. So the according to condition, x minus 5 is equal to as thrice old as Sonu. This is 3 times y minus 5. Because the Noori is already elder than Sonu, to equate them, we have to multiply the age of Sonu by 3. So from here we will get the equation x minus 5 is equal to 3y minus 15. So that is x minus 3y is equal to minus 10. This is our equation number 1 from first equation condition. In future 10 years later means 10 years in the future. So Noori's age is x plus 10 and Sonu's age is y plus 10. Noori will be twice as old as Sonu. Noori की जो अब एज है वो twice है as compared to Sonu, means x plus 10 is equal to 2 times y plus 10. So that becomes x plus 10 is equal to 2y plus 20. That is x minus 2y is equal to 10. This is equation number 2. Now we are having the pair of linear equation in 2 variables, so we have to solve this equation using the substitution method. So again from first equation, this is step 1. From first equation we will find the value of x, that is minus 10 plus 3y, and we have to substitute that value in the equation number 2. That becomes minus 10 plus 3y minus 2y is equal to 10. That becomes y is equal to 20. The y is equal to 20. Now again substitute that y here. X is equal to minus 10 plus 3 into 20, that is equal to minus 10 plus 60, and x is equal to 50. So that means present age of Noori is 50 and the present age of Sonu is 20. These are the present ages of Noori and Sonu. Again, we have to verify our solution. So simply look at here, 5 years in past, that age is 50 minus 5, that is 45. And here Sonu's age is 15. And that Noori's age is 3 times as Sonu. This is the condition, thrice. Yes, first condition fulfilled. In 10 years future, here Noori is 50 plus 10, that is 60 age, 20 plus 10, 30 age. Here Noori is twice as old as Sonu. Yes, second condition also satisfied, means our solution is correct. So this is the way, if there is a statement question related to ages, you have to divide the question like this: present ages, past ages and future ages, and you have to find the conditions. The next one is Meena went to bank to withdraw rupees 2000. She asked the cashier to give me the notes of 50 and 100 only. Meena got 25 notes in all. Find how many notes of 50 and 100 she received. Means this is a question that a girl, Meena, goes to bank to withdraw 2000. Means she total amount she has to withdraw is 2000, but she asked the cashier that give me the notes of 50 and 100 only. And the cashier give her 25 notes overall. We have to find how many notes of 50 and 100 each given by cashier to the Meena. So let rupees 50 notes are X and rupees 100 notes are Y notes. And look at here, if we are having 2 notes of rupees 50, means overall amount is 100 rupees. If we are having 3 notes of rupees 50, means overall amount is 150 rupees. Similarly, this time we are having X notes of rupees 50. So amount is 50X. Similarly, we are having Y notes of 100 rupees. So amount is 100Y. Now, the first condition is the cashier gave 25 notes to Meena, but according to her, there are only X plus Y number of notes, because X notes of rupees 50 and Y notes of rupees 100. So Meena get X plus Y notes, but Meena got 25 notes overall. So first condition is X plus Y is equal to 25. This is equation number 1. Now look at the amount. The amount Meena got is 50X plus 100Y. But according to Meena, she got 2000 rupees. So that means 50X plus 100Y is equal to 2000. This is equation number 2. Now we are having 2 linear equation in 2 variable. So we will solve this using the substitution method. First of all, the equation number 2 is simply divided by 50. That is 50 is the common factor. That becomes X plus 2Y is equal to 40. This is actually equation number 2. So again, from step 1, we will find the value of X or Y from the first equation, that X is equal to 25 minus Y, and substitute that value in the step 2 in the equation number 2, that is X 25 minus Y plus 2Y is equal to 40. That is 25 plus Y is equal to 40, and Y is equal to 40 minus 25, that Y is equal to 15. So value of Y is 15. Now put that value of Y here. X is equal to 25 minus 15. X is equal to 10. So what does this mean? This means that she got 10 notes of rupees 50 and 15 notes of rupees 100. So look at here, there are all 15 plus 10, 25 notes are there. First condition fulfilled. Now the amount is 15 into 10, 500. This is 1500 and the amount is 2000. Yes, second condition also fulfilled. That means y15 and x10 is the correct solution for this statement problem. The next one is a lending library has fixed charges per day. Charges for the first 3 days is and additional charges for every day thereafter. Arushi paid rupees 27 for the book kept for 7 days, and the fixed charges for rupees x per day and the additional charges for rupees y per day. Write the linear equation representing the above information. So this is the question where we have to convert the statement in the linear equation. So what actually is this question about? That there are some fixed charges and some charges that are per day according to per day. So let the fixed charges are, let fixed charges are x rupees and variable charges are y rupees per day. So look at here, Arushi paid 27 rupees, she kept the book for 7 days. Now she kept the book for 7 days, but the fixed charges are for first 3 days. Fixed charges are for first 3 days. That means for first 3 days she has to pay rupees x. Now after, and total number of days are 7, and she has to pay rupees x for first 3 days. Now the remaining days are 4 days. So for remaining 4 days she has to pay y rupees per day. So the amount is 4y. This is the total amount for 7 days. That is x rupees for first 3 days and y rupees for each day after 3 days. That means remaining 4 days the charges are 4y. So but according to her, the total paid she paid, that is 27. She paid total 27 rupees for 7 days. So this is the linear equation representing this situation. Again, if one more situation is there, if she rent a book for 5 days, she paid 21 rupees for 5 days. Now how to convert it? Again, for the first 3 days she will pay x rupees for first 3 days. Now the remaining days that are out of 5, if 3 days there are 2 remaining days. For remaining 2 days she have to pay y rupees according to per day. That charges are 2y. For y rupees per day, for remaining 2 days she has to pay 2y, and the total overall pay she is 21. This is the second equation. So here this question is mainly here for how to convert such situation in the pair of linear equation in 2 variable. Now you are having the 2 situations and 2 equations. You will easily solve these equations using the substitution method. The next one is graphical method. Now we have to solve the pair of linear equation in 2 variable using the second method, that is the graphical method. The first question is solve x plus y is equal to 4 and x minus y is equal to 2. Means we have to solve these pair of linear equation using the graphical method. So as in grade 9 we know that to draw a line on the graph paper we have to find at least 2 solutions for that equation. Then we will plot that solution on the graph paper and we join them using the pencil and square. So again, for both of the equations we will have to find at least 2 solutions for each equation. So first equation is x plus y is equal to 4. Now we have to find 2 solutions for this equation. And how to find the solution? For that we have to let a value of one variable, either x or y of our choice. So I will let x is equal to 0. Now substitute that value in the equation. 0 plus y is equal to 4. So y is equal to 4. So for this 0, 4 is one of the solution. Now for the second solution, let y is equal to 0. Now substitute again, x plus 0 is equal to 4, I get x is equal to 4. So 4 comma 0 is the second solution. Now for the second line, that is x minus y is equal to 2, again we have to find two solutions. So for the first solution, let y is equal to 1. So x minus y is equal to 2, that will give x is equal to 3. So 3 comma 2 is the one solution for second equation. So for first equation, solutions are 0 comma 4 and 4 comma 0. For second equation, solutions are 3 comma 1. The solution is 3 comma 1. Now we have to find the second solution. X minus y is equal to 2. Let y is equal to 0. That gives x minus 0 equal to 2, and the solution is x is equal to 2. Solution is 2 comma 0. And the second solution for this x minus y is equal to 2 equation is 2 comma 0. Now we are having two solutions for each equation. Now we have to draw the graph of these two pair of linear equations in two variables. So for that, we have to draw a Cartesian plane like x-axis and y-axis and draw the lines. So look at here. This is the x-axis, x dash, y and y dash, and this is the origin. Points are 1, 2, 3, 4, 5. Here negative points -2, -3, -4 and -5. Positive values of y 1, 2, 3, 4 and 5. Negative values of y, that is -1, -2, -3, -4 and -5. Now first of all, we will plot the points for one equation, that is 0 comma 4 and 4 comma 0. So 0 comma 4 is this point. Here on the y-axis, as value of x is 0, so 0 comma 4 is this solution, 0 comma 4, this point. The next solution is 4 comma 0, that is this one. 4 comma 0 is this point, 4 comma 0. Now join these 2 points, and this line will represent x plus y is equal to 4. Now for the second line, second equation, the first solution is 3 comma 1. X is 3 here and y is 1, and the solution is 3 comma 1 is just like here. This is 3 comma 1, 3 comma 1, and the second point is 2 comma 0. That is this point, 2 comma 0. Now join these 2 points. So this line represents x minus y is equal to 2. Now, so this is the graphical method. As we know, what is the solution of pair of linear equation in two variables? That is point common to both the lines. So look at here, for both these straight lines, the common point is 3 comma 1. 3 comma 1 is a common point. So 3 comma 1 is the solution. Now if we want to verify the solution, just put these values in the both equations. So look at here, 3 plus 1, that is 4. Yes, first condition is satisfied. Second is 3 minus 1, 2. Yes, second condition is also satisfied. So this 3 comma 1 is the correct solution for this question. Now this is the graphical method. In graphical method, again I will repeat, we have to draw two straight lines on the graph paper, and as in grade 9 we know that how to draw a straight line on the graph paper. For that we need at least two solutions for each line, and to get the solution we have to take one value of one variable of our choice to get the corresponding value of second variable, that will combinedly give a single solution. As we have to repeat the same steps to get the second solution, And again we will repeat the steps twice for the second equation to get the 2 more solution for the next equation. As we are having overall 4 solutions, 2 for each equation, we will plot the first 2 solutions and join them using pencil and scale. That will give the graph of first equation. Again plot the third and fourth point, that will give the graph of second equation, and the intersection point gives the solution for the system of equation. This is the actual graphical method to solve the pair of linear equation in 2 variable. The next one is now look at here again, as pair of linear equation in 2 variable represents the 2 straight lines, and there are 3 possible cases for the related to the 2 lines. As already discussed, either the lines are intersecting, parallel or coincide with each other. In the first case there is only common point, one common point, so there is a single solution that is called consistent solution, consistent system. And for the second, the lines are parallel, there is no common point, so there is no solution, and the system is called inconsistent system. And the third case, every point is a common point to both the lines, so there are infinitely points in common, so there are infinitely many solutions, and this system is also called consistent system. Now there are some situations, some conditions where we will check that the pair of linear equation in 2 variable represents parallel lines, intersecting lines or coincide lines without actually finding the solution. We will easily check. So what are the conditions? Look at here. The first condition for intersecting lines, let a1x plus b1y is equal to c1 is the first equation, and a2x plus b2y is equal to c2 is the second equation. There are 3 cases when lines are intersecting, parallel and lines are coincide with each other, that they are just upon each other. Now for first condition, the lines are intersecting means there is a unique solution, one solution. The condition is that first 2 ratios, the ratios of x coefficients of x, that is a1 by a2 is not equal to ratio of the coefficients of y, that is not equal to b1 upon b2. The first condition for the intersecting lines is the ratio of coefficients of x is not equal to ratio of the coefficients of y. For the parallel lines, the condition is the first 2 ratios, that is the ratio of coefficients of x is equal to ratio of coefficients of y, but not equal to the ratio of the constant terms. So condition is a1 upon a2 is equal to b1 upon b2, but not equal to c1 upon c2. The first 2 ratios are equal, but not equal to the third ratio. For the constant lines, the condition is all 3 ratios are equal. a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So this is there are the 3 conditions for each case. The first 2 ratios are not equal, that means there is a intersecting lines, they are representing the intersecting lines, there is only one solution. If first 2 ratios are equal but the third ratio is not equal, that they are representing the parallel lines, means there is no solution. If all 3 ratios are equal, that means there are infinitely many solutions. So let's discuss some questions related to these. On comparing the ratios a1 by a2, v1 by b2 and c1 by c2, find out the following pair of linear equations represents intersecting at a point, parallel or coincident. Again, these 3 questions are related to the last slide, means we have to check whether these lines represent intersecting lines, parallel lines or coincident lines without actually finding the solution, just after checking the ratios. So let's first question, what is the ratio? That is a1 upon a2, that is equal to 5 upon 7. b1 upon b2, that is minus 4 coefficients of y over 6. Now look at here, clearly a1 upon a2 is not equal to b1 upon b2. First two ratios are not equal, so these two lines represent intersecting lines. Intersecting lines means one solution. Now the second lines are, for second equations, this one part, a1 upon a2, that is equal to 9 upon 18. Coefficients of x, that is equal to 1 upon 2. Second ratio, that is b1 upon b2, that is coefficient of y, 3 upon 6. That is again 1 upon 2. Third ratio, that is ratio of constant terms, that is equal to 12 upon 24. 12 upon 24. This is again equal to 1 by 2. Now look at here, all three ratios are equal, as a1 by a2 is 1 by 2, b1 by b2, that is also 1 by 2, and c1 by c2 is also 1 by 2. So these two lines represent constant lines, and they are infinitely many solutions. Infinitely many solutions. Now for the third question, so first pair of lines representing the intersecting lines, second pair of lines representing the infinitely many solutions. Now let's for the third equation, that is a1, this is for the third equation, a1 by a2, that is equal to 6 coefficient of x upon 2, that is equal to 3 upon 1. b1 by b2, that is coefficient of y, minus 3 upon minus 1, that is again 3 by 1. Third ratio, that is c1 upon c2, that is equal to 10 upon 9. So clearly look at here, first two ratios, that is a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. So these two lines represents parallel lines, and there is a no solution, because in parallel lines there is a no common points. So this is how, without actually finding the solution, we will get how many solutions a pair of linear equation in two variable has. Either they are having one solution, if first two ratios are not equal, they are having not solution if first two ratios are equal but not equal to the third ratio, and they are having the infinitely many solution if all three ratios are equal. The next one is, given the linear equation 2x plus 3y minus 8 equal to 0, write another linear equation in two variables such that geometrical representation of pair of formed is intersecting, parallel and coincidence. Means what is given in this question, we are given a single line, a single equation, that is 2x plus 3y minus 8. We are given single line. We have to find the second equation according to these conditions. So look at here, 2x plus 3y minus 8 is equal to 0 is the first, and corresponding to that we have to find the second. The first is intersecting, second is parallel, and third is coincidental. Now we have to find a first equation that these pair of linear equation forms the intersecting lines. Now we know that a pair of linear equation two variable represent intersecting line if first two ratios are not equal. So we will write such equation here that the first two ratios are not equal. You will write the random equation, but after that you have to check the condition also. Look at here, 3x minus 7y plus 9 is equal to 0. This is random equation I have written here, but I will check the conditions also. The first ratios, look at here, a1 by a2, that is equal to 2 upon 3. b1 by b2, that is equal to 3 upon minus 7. Clearly the ratios, first two ratios are not equal, so these two lines represents the intersecting lines. Then for the next one, parallel lines, the condition of parallel lines is that first two ratios are equal, that is not equal to the third ratio. So look at here, if I will write 4x, clearly the ratio is 1 by 2. Now I want that second ratio is also 1 by 2. That is only if there is 6y. But I want that the third ratio is not equal. That is, third ratio is 1 by 2 if I will use minus 16. So except minus 16, I will use any number that, look, let 15 is there. So this is 4x plus 6y is equal to 15. This is the second equation. Now check, are they representing the parallel lines? Yes or no? So again, ratio a1 by a2. That is equal to 2 upon 4, 1 by 2, b upon b2, that is 3 upon 6, again 1 by 2, c1 upon c2, that is minus of 8 upon 15. So here first two ratios are clearly equal, but third ratio is not equal. So these two lines representing the parallel lines. So I will repeat how to find the second equation. I will write first number, let 4x is there. Now I will check, let the ratio is 2 by 1. As second ratio is also equal, I want the second ratio is always also 1 by 2. So there is 3, and for 1 by 2 I need 6y. That's 3y upon 6y, that is 1 by 2. So second is 6y, but I want that third ratio is not equal. So that's why I will put a such number here, that ratio, that third ratio of constant is not 1 by 2. So this is these two lines representing the parallel lines. Now for third constant lines, the condition is all three ratios are equal. Again, let this is 6x. Now ratio is 1 by 3, 2 by 6 is 1 by 3. Now I want that all the ratios are 1 by 3. For that, 3, I will put 9y. Again 3 by 9, that is 1 by 3, and for here I will put 24. Now look at the conditions. a1 by a2, that is 2 upon 6, 1 by 3. b1 by b2, that is 3 upon 9, again 1 by 3. c1 upon c2, that is minus 8 upon minus 24, that is again 1 by 3. Now all three ratios are equal. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So these two pair of linear equation represents the coincident lines, means there are infinitely many solutions. And this question is very much important when you are given a single equation and you have to find the corresponding equation which will satisfy the given conditions also. The next one is for what values of a and b does the linear equation have infinitely many solutions. Now the pair of linear equation is given and we have to find the values of a and b such that there are infinitely many solutions. There are infinite number of solutions. As we know that for infinite number of solutions, all three ratios are equal. For infinite solution, all three ratios are a1 by a2 is equal to b1 by b2 is equal to c1 by c2. All three ratios are equal. So using this, 2 upon a minus b is equal to 3 upon a plus b is equal to 7 upon 3a plus b minus 2. So using this condition, I will look at here, this is the ratio of coefficients of x, that is 2 upon a minus b is equal to ratio of coefficients of y, that is 3 upon a plus b, and is equal to ratio of constant terms, that is 7 upon 3a plus b minus 2. Now let's first two equating first two members, that is 2 upon a minus b is equal to 3 upon a plus b. That will give us 2 into a plus b is equal to 3 into a minus b. that is equal to 2a plus 2b is equal to 3a minus 3b. That give us a minus 5b is equal to 0. This is the first equation. Now, equating the second and third member, we will get 3 into 3a plus b minus 2 is equal to 7 into a plus b. That is equal to 9a plus 3b minus 6 is equal to 7a plus 7b. 9a minus 7a, that is 2a, 3b minus 7b, that is minus 4b is equal to 6. That is the second condition. Now again we are having the pair of linear equation in two variable. We will solve these using the substitution method or the graphical method. So let's try the substitution method. From here the value of a is 5b. Now we will put that value in the second equation. Okay, now put this value here. This is 2 into 5b minus 4b is equal to 6. That is 10b minus 4b is equal to 6. 6b is equal to 6. So b is equal to 1. The value of b is 1. Put this value of b here. That is 5 into 1 is equal to a. So value of a is equal to 5. That means the value of a is equal to 5 and value of b is equal to 1. This pair of linear equation has infinite number of solutions. So this is how we have to use the condition according to the given statement. So they are saying that there are infinitely many solutions are there. So we will use the condition for that number of solutions. The next one is, for what values of k will the following pair of linear equation have? Again, infinitely many solutions. So again, solution is infinitely many solutions are there. So third condition, that the first three ratios are equal. Coefficient of x is k, and here coefficient of x is 12. That is equal to coefficient of y 3, coefficient of y is k, and the third, that is minus constant of minus k minus 3, and here is minus k. Again, equating the first two members, we will get k square is equal to 36 and k is equal to plus minus 6. So value of k is plus minus 6 from first two members. Equating second and third member, 3 by k is equal to k minus 3, negative negative cancel out. This gives 3k is equal to k square minus 3k. From here we will get k square minus 6k, that is equal to k into k minus 6. That gives k is equal to 0 or k is equal to 6. Now look at here. Here the values from first two members, the values of k is 6 and minus 6, and from second and third members the value of k is 6. Now a common value of k is the solution. So common value of k is equal to 6. So that is the actual value of k that is required for infinitely many solution. So for infinitely many solution of this question, the value of k must be 6. So dear students, this is all about the video. This is actually the first part of the third chapter of grade 10, that is the pair of linear equation in two variable. Dear students, this is all about the video. Actually today we have covered only first two methods to find the solution of pair of linear equation in two variable. In the next video we will discuss the another two methods, that are the elimination method and the cross multiply method. So thanks for watching the video. Please like, share and subscribe the channel to watch more videos. Thank you.